All right, we're going to start off by talking about how to graph a square root equation like this. So the first thing we're going to do is we're going to make our table. So x, y. And the important thing to keep in mind is that we know the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. So we want x plus 6, this inside part, we want that to be 0 because we know what the square root of 0 is. So what number plus 6 gives us 0? So that's our first value here, negative 6. Our next one, what plus 6 would give us 1? That negative 5 is our next value. What plus 6 would give us 4? And so we can continue this. What plus 6 gives us 9? And then we're going to just put these numbers in. So negative 6 plus 6 is the square root of 0 plus 2 gives us 2. Here we have negative 5 plus 6. The square root of 1 plus 2 gives us 3. Negative 2 plus 6, the square root of 4 plus 2 comes out to 4. And then here it's just going to be 5. So if this was a negative in front, it's going to be the same x and y values. But when we're putting it in, you get the negative square root of 0 plus 2, which is 0 plus 2, which is 2. So that's still the same, but here, negative square root of 1 plus 2, negative 1 plus 2 gets us just 1. So it's going down. So this would be negative square root of 4 plus 2. Negative 2 plus 2 gets us 0. So that pattern goes down. So that's how you get like both directions on your square root graph there. So to find our missing number here, so it's just important to understand what a log is. So it's the opposite of an exponent. So to get rid of log base 5 of something equals 3, 5 to the power of this. And if you do it to one side, you have to do it to both. So the 5 to the power of log gets rid of each other. So we have question mark equals 5 to the third power. So question mark is 125. So to get rid of log 2, well, log base 2 means we're going to take 2 to the power of. And we're going to do that to both sides. So these get rid of each other. 1/8 equals 2 to the what power? And 8 is 2 to the third power, so this would be 2 to the negative third power. And then this last one, log base something of 81 is 2. So we're going to take question mark to the power of both sides. And those get rid of each other. So 81 equals what number squared? So we actually know that 9 is that missing number. So that's kind of what a log is. It's a fundamental understanding. So we're going to use that to algebraically calculate the inverse. So pause the video. I want you to try this out on your own. Make sure we're getting it from last week. All right, so here's what I got. And a different way of understanding this, you could have used just rewriting in the definition of a log. The way I think about it is taking the log base 6 of both sides. Because this log base 6 and this 6 to the power of get rid of each other. Over here, after dividing by 5, I took the log base 2 of both sides, and that gets rid of 2 to the power of y. So that's a different way of thinking about it, a different understanding. All right, so what we have here is on your calculator, your log button. It's really, it doesn't say it, but it's log on your calculator, and that is log base 10. Your calculator doesn't do other log bases, so it's just naturally log base 10. So if you ever just see log, it means log base 10. So what we have here is we have a chart of all the logs of numbers 1 through 12. And so Natalie was curious about the table, so she checked a couple of entries. You can do this too, so all you do in your calculator just to get used to this is do log of 1, see if you get 0. Log of 2, you should get 0.301. So just maybe take a second to check that, make sure you can use your calculator for that. So she decided to look for patterns. She thought log 2 plus log 3, so if we add these two, she thought log 2 of log 3 might get us log base 5. So check, is that true, yes or no? Take maybe 10 seconds to check that. If you need to pause the video, do it. So after doing log 2 of log 3, so if you have not done this in your calculator, added those together, do it. And then she looked at the table and she noticed something interesting. What do you think she noticed, or what do you notice? So if you said it was log 6, you would be correct. Log 2 plus log 3 got us log 6. So what kind of pattern are we seeing here? So let's see if we can predict now. So we tried log 2 and log 10 got 6. What do you think log 3 plus log 4 is? So let's get that decimal answer first. So if we do 3 plus 4, that's going to get us about 1.079. So that's what we're going to write here, 1.079. That's log 3 of log 4. But where do we see that on our table? Well, it's down there at log 12. So log 3 plus log 4 gets us log 12. Is that pattern holding true? So we're going to continue this and write a general rule. This is our first logarithm property. And it's important to know these go forwards and backwards. So log x plus log y equals log of, what did we have to do with 3 and 4 to get 12 and 2 and 3 to get 6? Well, we multiplied them. So you could take it multiplying and split it up into addition. You could take 2 adding and combine them into multiplying. Let's find another one. So let's test this out with some new numbers. So we have log base b of x plus log base b of y equals log base b of xy. So we want to see if it's true. What if the base is not 10? So we're going to see if this is true by using our definition of logs, by rewriting it. So here, log base b of x, we have log base 3 of 9 plus log base 3 of 27 equals log base 3 of 9 times 27. So take a moment to write that down, and then we're going to use that going forward. So first we're going to just deal with the left side. So 3 to what power is 9? So this can just simplify to 2. 3 to what power is 27? 3 to the third power is 27. And then we're going to do 9 times 27. So I'm just going to get a calculator. 9 times 27 gets us, so this becomes log base 3 of 243. And we can see 3 to what power is 243? It's actually 5. So 2 plus 3 equals 5. This holds true. So that is our first log property. So, like I said before, we can go both ways. We can expand and compress. So here's one, log of 7m. That can expand 7 times m. We can expand that into log of 7 plus log of n. That's all we need to do. Here we have log base 2 of 3 times 9. We can expand that to log base 2 of 3 plus log base 2 of 9. So expanding is important. And then we're also going to compress. We're going to bring them together. So log of 4 plus log of 8, we're going to combine those. When it's addition, becomes log of 4 times 8, which is log of 32. Log base 6 of 10 and log base 6 of m just comes log base 6 of 10m, combining it together. Then we're going to use that to actually evaluate these bottom ones. So we have on the left log of 1/2 plus log of 20 becomes log of 1/2 times 20, log of 10, and log, if you just see log, it's log base 10. 10 to what power is 10? This just becomes 1. On the right one, well, we're going to combine these, so let's do log base 3 of 3x, 3 to the power of x times 3 to the power of y. And with those exponents, we can actually add those exponents. When you multiply two things, you can add, with similar bases, you can add the exponents. So log base 3 of 3 to the x plus y. And remembering log 3 and 3 get rid of each other. So you just have x plus y is your answer.